Good afternoon, everyone. Thank you for joining our regular webinar Intro to Diana. Today, I'm going to give the presentation, which will be followed by a short demo from my colleague Jingming. Today, he will demonstrate the application of space functions to define vehicle loads in a structural analysis, showing you a simple case and also the application to a realistic structure. As you know by now, if you are familiar with our webinar, your microphone will remain muted during the whole session, but you have the possibility to type questions. There is a question box in GoToWebinar. I will keep an eye on the questions, and if they are relevant for the whole audience, I will try to answer them on the fly. Otherwise, I will get back to you per email after the session. The webinar will be registered, and within a few days after post-processing, it will be available on our YouTube channel. So first, let's start with a short presentation to give you an overview of the capability of Diana. And after that, as I mentioned, I will hand over the stage to my colleague Jingming. Diana is a short form of displacement analyzer and is a general finite element program with a strong focus on civil engineering, geotechnical engineering, and petroleum engineering application. Our aim is to provide a range of efficient engineering solutions for the daily or specific type of engineering problems. By increasing the accuracy of the final results, our client could optimize the cost of their project, because at the end of the day, money is mainly the main issue. Our core values are summarized on this slide, and I would say can be identified in 3 points. Reliable, so we try to build an innovative state-of-the-art software, providing the user with a consistent and reliable result. So this is very important. Collaborative in the sense that we stimulate teamwork and also exchange a lot with our end users. So basically, it's a kind of collaborative process. And solution-oriented, having a proactive mindset to solve the client's challenge is really the vision and the way of working in Diana and how we develop our Diana software. We have a good network of scientific experts. We have a global support network. We have a website with thousands of articles and regular webinars and clients all over the world. So we can say that basically Diana is available on every continent and almost every country. So we are really worldwide. On the next slides, we present a list of some of our valuable clients. And I would say this list is non-exhaustive. We have clients in different countries, as I just mentioned, all over the world, from different organization types, from governmental organization, academic, can be university of research or research organization, but also from the private sectors, like consultancy companies or construction companies. From different sectors, oil and gas, energy, underground structures, and we appreciate their effort in trusting and using Diana to in their project. So basically, we work together to find solution to their challenge. So let's now move to the Diana applications, and let's start with the geotechnical and tunneling. For that, we have a very good integrated solution for all types of geotechnical and tunneling applications. So you can use the integrated environment of Diana for any type of tunneling and underground structure. For ground freezing, also called the three-phase analysis, we have a solution for real soil structure interaction. So if you have So if you have a sort of interaction between the underground and the surrounding soil or rock, you can model it with a concept of nonlinear interface behavior, for instance. Coupled groundwater flow stress analysis is also a possibility in Diana, and many more, such as slope stability, for instance. Next to that, we have a very comprehensive solution associated to reinforced concrete and early age behavior of the concrete cracking. That's mainly when the model and the casted concrete go through the process of hydration. For any types of concrete box, girder, or composite structure, so it could be interaction of concrete with metal or combination of concrete with fiber, we have also a proper solution. For dam structure, it's also very important because of the process of casting, curing, hydration, and impounding. And again, Diana can be seen as the solution. I will get back to that later. We have also a good coverage for design check, including the reinforcement based on the Euro codes, mobile loads and design load generator, and indeed the cross-section design check. You can use it in conjunction with your bridge application, or you generate structural analysis, or your general structural analysis application. We have a different solution in order to give you a good estimation about nonlinear response analysis of the model without entering into the nonlinear detail parameters input and setup iteration like the sequential analysis. Temperature and stress coupling let you analyze how the concrete goes through aging. This is also very important. Cooling pipes is also another powerful feature that we offer in both 2D and 3D in order to control the hydration process. Crack initiation and propagation in concrete, one of the powerful features in Diana, and also fire effect, how the fire could affect the durability of your structure. And I would say to get an answer to this question, I mean, Diana is the right tool. Among other applications, we can refer to masonry and historical constructions. In Diana, we offer different solutions at meso or macro levels. You can use Diana to model the interaction between the individual bricks and the mortar joints, so quite detailed. For dams and dikes, Diana offers this solution. It covers all the aspects of construction for all types of dam structures. You can consider the fluid structure interaction, dynamic effect, and also induce damage to the structure. And from Diana 10.10, which will be released early next week, basically you can also take into account the water compressibility, so fluid compressibility. So this is one of the nice features that is coming in our next version. And I invite you already to keep an eye on our website for the official release and for the release webinar, which will be mid-January. Fire analysis is another area that, based on its importance these days, has become one of the main topics for structural check. Diana can be considered as one of the most reliable solutions. For earthquake analysis, you can use Diana for general dynamics or seismic. Among the other, the advanced type of application, Diana is also very well known in the field of oil and gas and nuclear structures. Based on the type of complexity, you can simulate a 3D geomechanical depletion, borehole stability. For nuclear structure, you can analyze concrete containments or underground waste storage. So we can say also that for oil and gas and nuclear structure, Diana offer a proper solution. Let's now take a look at our Diana environment, or Diana IE interface. So I would say the look and feel is very natural. It's very intuitive in the sense that basically you have a toolbar on top with the main field and some shortcuts. So the whole toolbar can be customized based on your preferences, but you can find all the possibility under the different menu. You have a series of windows from the geometry mesh window to the analysis window, the output, the message window, Python command, and property window. All these windows are very flexible. You can move them from right to left, from top to bottom. I mean, you can really customize the environment the way you want, in a sense that basically you can show the window that you want in the environment, and you can place them at the position which is the most comfortable for you. And of course, you have the main window. This one will remain fixed. I would say that's where the magic happens, in a sense that that's where you do the modeling in terms of geometry, the meshing, and that's where you present the results. So everything is done in one environment. And as I briefly mentioned, you have a Python window, a command console, because the whole graphical interface of Diana EE is interfaced with Python. So it allows you to communicate with the graphical user interface, and also to automatize a lot of process. With respect to the environment, we try to deliver the state-of-the-art solution. So in terms of graphical tools, we have an intuitive graphical user interface with a lot of display options and advanced selection methods. The modeling functions are based on Parasolid. We have also an automated and robust geometry checking and repairing tools if you are dealing with an imported model from a CAD program. In terms of meshing tools, we have a powerful and automated mesh engine. We have embedded reinforcement generation, and also for pile and sheet pile wall. For load and boundary condition, I would say that we offer full support of load and boundary condition. Everything is done at the geometry level with some flexibility at the mesh level. But again, I will show you in the next slide that the philosophy is to do everything at the geometry level. And it also offers a perfect compatibility with Excel, so you can copy-paste data. And for post-processing, we offer a complete solution to result interpretation. I would say that the only limitation might be your imagination. No, but more seriously, I mean, we have quite a range of functionality, so you can really interpret and present your results the way you want. We offer material model classification in separate dialog boxes with unique aspects that can be activated at this stage. You can define load combination for design or for distinctive analysis. Functions, you can generate functions, whether it's special or non-special function or space function. And today will be an application of that in the live demo. The property window gives you more control on some of the aspects and allow you to basically dive into some of the information of the entity that you have defined in your model. And the analysis window give you a kind of intuitive environment to set up any type of analysis, including, for instance, interactive phase analysis. So in one dialog box, you can see all the phase and all the part of your model that are activated or not in each phase of your analysis. Let's now talk about the workflow. So let's take a little bit of time to go through this flowchart. Because the story that I'm going to tell now apply to every model in Diana. Doesn't matter if it's a simple one or complicated one, it's always the same story. So you first define your geometry. So all the components of your geometry, all the shapes. On this geometry, you assign the properties. By properties, I mean physical properties, material properties, boundary conditions, initial condition, loads, so everything assigned to the geometry. When all the properties have been assigned to the geometry, you tell Diana how you want to discretize your model, so you want to mesh, and then you generate the mesh. Once you have generated the mesh, you can set up your analysis. You tell Diana what to do with the finite element model that you have built, basically. You run the analysis. If everything goes fine, automatically the results are loaded to the graphical user interface, and then you can check your results. So this is the standard workflow of Diana, and doesn't matter how complex is your model or your analysis, the story is always the same. So it means that when you want to change something, I don't know, a material parameter, a load or a boundary condition, you do that at the geometry level. So before this change is reflected to your finite element model, so to your mesh, you need to remesh. Just be aware of that. So everything is done at the geometry level. So to transfer that to the finite element model, you need to mesh. So just be aware of this. We have many options to create the geometry of your model, whether you start from a white page in Diana or you want to import a CAD model. So if you import your geometry from third-party CAD program, we have a couple of supported formats. Among them, Diana can handle DWG, DXF, STEP, and IGS file. You can also import IFC file format if you are using Revit. Furthermore, if you are dealing with terrain geometry, for instance, you can import cloud of nodes and generate Bezier surface from them. So this can be a very powerful tool, especially if you are involved with a geotech project or oil and gas project, for instance. After importing the geometry, there is a geometry check. So you can always check the tolerance and the quality of the imported shape. You can fix it, improve it based on certain feature that we have in Diana to enhance your imported geometry. Because you will notice that if you work with CAD program and you import that to a finite element package, there's always some tolerance issue and a problem with the geometry. So Diana offers tools to check the geometry, but also tools to fix these issues. So I mean, we offer a complete solution. And of course, if, as I mentioned, you want to start from a blank page, you can use the basic tools we offer in terms of modeling primitive in Diana. So you can generate 3D solids, whether it's a block, a cylinder, a cone, a torus, or a sphere. But we also offer 2D and 1D primitive from the polygonal sheet to the point. And at any stage, I mean, the shapes that you are created are listing under the geometry tree. And by selecting the shape, you can access more detailed information in the property window associated to the selected shape. So you have a complete overview. It's not a black box. I mean, everything is transparent. We have sweep options. So, for instance, this is a nice option where from a reference shape in 2D and a GUID wired curve in 2 clicks, basically you can build such a complex 3D structure. So these are powerful options. You can generate complex geometry with a minimum information using smart functions like lofting operation, for instance. Here we have a couple of examples of this lofting operation. And you see that with a minimal geometry information, you can build quite advanced and elaborate 3D geometry. Our selection window is interactive and object-oriented. You can directly select them based on the selection filter, which is quite handy because, especially when you deal with complex models, the selection can be a little bit tedious. So having a proper filter only allows you to select specific entities, which is a must when dealing with a complex geometry made of multiple shapes and multiple types of sets. We are using auto clash detection. You don't have to worry about nodal connectivities of the different components of your geometry interacting with each other. Diana automatically takes care of that for you, ensuring perfect continuity and connectivity. So this is done automatically and internally. There are other options in Diana to improve your geometry. For instance, the Sue 2 or more sheets, or convert body and sheets. But these are just two options out of many. For any operation in the model with respect to the loads and boundary condition, you can use the input option to have the trace and track of the imposed loads or boundary condition acting on your reference geometry. This is also a nice feature. Other modeling operation enables you to rotate or to move face or adjust your shape. I mean, this can be done interactively in the graphical window, or in the working window, or via the action box. You can select and extract extruded faces of edge. You can match different parts of your model with respect to each other using the aligned face function when you have different objects in your working environment. With respect to the function, it can be assigned to the geometry to simulate the geometry thickness, for instance. Here we have an example of a bridge where the thickness and eccentricity of element is defined via a function in combination with shell elements. So it's a kind of elegant way of modeling. Or you can define and use it to define the phreatic water level in 2D or 3D modeling environment. This is also a powerful feature in the context of geotechnical application. Another strong feature in Diana is the Python scripting, as I mentioned in introduction, and the geometry optimization with respect to the effectiveness of the model when it's subjected to such a load, and how you can reinforce and retrofit the model because of the load distribution pattern in the model. There are many powerful features that you can induce and use in conjunction with other tools that we have in Diana based on the Python scripting. I invite you to visit our YouTube channel. We have a couple of webinars dealing with application of Python and usage of Python by some of our clients, and they are very instructive and show you the advantage on a daily engineering journey that you can take with the Python in terms of automatization and parameterization. For meshing, we have different types of mesher. These are smart processes. They recognize the generation of your geometry. If your geometry is based on extrusion, or extrusion mesh comes into the pictures automatically and generate a nicely patterned structure mesh, as you can see on this slide. I mean, the geometry started from a 2D shape that was extruded, and then automatically the extrusion mesher comes to the picture. We have adaptive element size that enables you to increase the density of nodes and elements at certain corner and edge in order to have a smooth transition mesh. Here, for instance, you can see an example on this geometry. Without and with these options activated, you can see that the density of element is much higher without changing the mesh sealing of your model. Here we have another case of a terrain geometry. So you see the difference with or without. So without, basically, you can hardly capture the shape of the original geometry. And with this option on, you have a better accuracy without changing the mesh seeding, as I mentioned. You can also use grading to optimize your mesh. You have full control on the distribution of the nodes and elements. After meshing, you can visualize the type of section that you have assigned to the model based on the different profiles that we have in our library. This is done using the real dimensions, and it enables you to check the orientation and eccentricity. This is very nice because when you are dealing with beam and shell model, basically you can end up with a model which looks like lines and plane. So having this realistic 3D cross-section makes your model much more realistic, and also allow you to really see your structure in 3D. At the mesh level, you have different way of presenting that enables you to inspect or present your model in the most suitable way. from wireframe, free face edge, feature edge, or different solid shading view or shrunken shading view. Also, there are different mesh engines, which enables to generate structured or unstructured type of mesh set. Here are some nice examples that you can generate using Diana. Another powerful feature is incremental meshing. This is very interesting when you are dealing with complex models and you need to come to do some modification at the geometry level for any reasons. Thanks to this incremental meshing, you don't need to remesh the whole model. Diana automatically goes for the meshing of the geometry parts of your model that have been subjected to modification. So this way you can save a lot of time in terms of meshing or remeshing of your model when subjected to change. So for instance, here we have an example where just moving or changing something on a single reinforcement bar can lead to a factor 6 difference between meshing from scratch to remeshing. So you can imagine that the bigger and the more complex is the model, the more benefit you can take from this option, which is automatic. You don't have to take any steps to activate it. At the end, we have a series of online documentation, including verification report, as well as our background theory manual, a context-sensitive help, and I think at the moment we have more than 100 tutorials online available on our website. So next to the software, we also offer a complete online documentation and assistance to guide you through the different possibility offered by the software. So this is it for my presentation. Let me quickly scan if there are any questions. I don't think there are any questions so far. So I'm going to give the presentation to my colleague, Jingming, who is going to go through the live demo. So Jingming, the floor is yours.
Thank you, Jean-Claude. Hello, everyone. My name is Jingming. I'm a technical support engineer in Diana. So in this section, I'm going to introduce you how to set up a space function in the Diana. So first, I will show you a really simple model. So it would be a beam model, which first I have this new completely empty model. I create a block and then make it a beam in x direction 5 meters. And as usual, we were going to fix the displacement of the face in this end, and we fix the displacement in x and z direction. Oh, sorry, so this x and y direction. And then, yeah, we need to create a new shape and create. And then we also need to set up a edge that is not allowed to move in the Z direction. So that now we have the support ready, and we want to give this beam a material model. So we create a material. Here we use, for example, we use concrete and masonry model, and we use linear elastic isotropic model, which is the simplest. And in Diana, you can use many other materials you have. For example, you can use, for example, the total string-based crack model, where you can simulate the crack development in the concrete. So for now, I just keep the simplest. We use the linear elastic isotropic to show you the other aspect of Diana. So here we just randomly put a number of 3 to the E10, and the Poisson ratio is 0.3, very common among the concrete. And then we assign, and now we have the material and the bond and the support. What we want to do next is that we want to apply a load. So here, here is where I want to show you how to apply space function based on load. So first we create a load set, and we want to apply the load, for example, on the top of the beam, and we use distributed force. For example, I use 1,000 Newton per square meter distributed force on top of it, and the direction will be Z. So in this case, if I click apply, then you can see this force is applied vertically downward on top of the surface, on the top surface. So if I want to distribute this force, for example, at the end of the support is weaker, at the end of the beam it is stronger, in this case, we can make use of the space function. So we just click this. For now, it will not show anything because I do not have any space function defined. So what we can do is that in geometry function, we add, and we have a new function, we call it load. In this function, we want to define a space load definition on the x direction because the beam is set up that way. So we have the first data point 0 meter at x direction, which is the support location, and we want it, for example, 0.1. So like 1/10 of the applied the force distributed force at the top surface, and at the other end will be 5 meter. Will be the other end of the beam. We use a factor of 2, and then we can see this factor develop from 0 to 5. And we click OK, and once again we click this, and we click load and create again. And now you can see, because now I have 2 load, I need to delete the previous one. And now you can see the based on the graphic, you can tell that from this end the load is much weaker compared with this end. So this is the very simple way of applying space the function on your load, and this is only for a 1D situation. For example, the top of the surface is a plane, is 2D. So what you can also do is that you add you do a space function defining a plane that can map your top surface into this one. So for example, we still have these 2 data points, 0 to 1, and y1 is 0, y2 is 1, which is the both end of it. So in this tip, which in the graphic you will see it will be corresponding to this tip of the beam. So we set to 0, and for this tip we want it to be 1, and this tip will be representing this one, and this will be this. So if, for example, if I want to apply extra force on this tip, I can make it 2. And then you can also see from the result, not the result, but the graphic representation of this space function. So you have this tip, the lowest, and this 2 tip are 1, and this tip is 2. Anything in between is linear interpretation. So I just click OK. And I click this load 2 again, and I use load and update, and now you can see the line underneath your distributed force. Then you can see the line here is short. This one is 1, and this represents the 2 factor. So we can see it's very straightforward if you want to apply a space load based on in this method. On the other hand, you can also set up your, for example, your material property with space function. For example, again, if you want this this part of the beam extra strong, then you can set a space function based on x direction, and 0, for example, 1 in this direction, and this one will be 0.1. So in this case, then this case will be very strong, and this tip and this tip will be relatively weak. So whenever you see this bottom, then you can apply space function on these parameters on your model. So this will be the very simple simple model. And to apply a traffic load, you can also do a few things. So one of the easiest way to do is that you just create, for example, this is a bridge, and you create, for example, polygon sheet, and you use a plane of x direction. For example, your wheel is 0.4 meter width and 0.2 meter length, of the other way around, and you click create, and you move this sheet up or here, and then, for example, here that this will be the contact area of your view and also your bridge, and then you use projection. For example, here you project this the top this bridge solid with 2 of this sheet, and the direction will be -1, and so that there will be a face that imprint on your bridge face. And with this, with the load, yeah, you can assign for example, you can assign a load on this specific face that we just create. For example, face distribution, you just click one, and then you can apply a distributed force based on your vehicle load. Well, this will be relatively tedious if you have a lot of car on your deck. And what you can do is that you can make use of the space function. For example, you just define a distributed force on the deck of your bridge, and you assign a value, and then, for example, you create a space function called vehicle load. In this case, it will be a 2D load. So I have already created. So it looks like this. So for location where you have the wheel, then I assign a factor as 1. And for other location where you don't have contact between the vehicle and the bridge, you set it to be 0. And in this case, because I use this grid relatively rough, then you can see this transition between the maximum 1 to 0. It is linear interpreted. If you use much denser mesh, not mesh grid here for your input, then you will observe much sharper from 1 to 0. And yeah, so this is this will be the space function to simulate to represent your the load of your vehicle through the contact between the wheels and the bridge deck. And yeah, once you use this space function, you click update, then you can see that how they are distributed across the deck. So you can see this location, they have non-zero distributed load on the deck. For other places, they have 0. So in this case, it's very elegantly apply a vehicle load on your deck without having to create a lot of imprint face on top of your bridge to apply a constant distributed load. So this is a really convenient way of doing. So I can also show you the result. So this is external force after I apply the vehicle load on the deck. You can see they are in they are corresponding to the space function that is applied, and they have I have a multiple step here. So basically, for the first step, I set the factor is 1, and then the second factor is 2 different load step. And with this, you can also see how the crack is developed from increasing load. So basically, the heavier of your car, the more crack you can see. For example, in this case, is developed in the bottom of your bridge. So yeah, so this is yeah, very simple and straightforward tutorial of introducing how to apply space function on your load. Yeah, in this case, we'll be simulating the vehicle load. So there's also other parameters you can use this space function. For example, ambient time dependencies and material properties I just showed. So with this space function, you don't you can save a lot of effort from defining a lot of material, a lot of loads. If you can try to figure out a space function that can map your model on top of it, then you can define a load in this way, or material. So yeah, that will be it. Thank you so much for your attention.
Thank you very much, Jingming. I mean, a very nice and comprehensive demo, as usual. So before we end this webinar, let me just show you, if I manage. Somehow it seems that my mouse get frozen. Show my screen. So it should come back. I just want to bring to your attention that our 10.10 version is coming soon. It's a matter of days now. And we have already a release webinar, which is planned on 22nd of January. So you can already enroll for this webinar. For the one who have a current license of Diana, I mean, the 10.10 version will be available early next week. So don't miss the date, because we have a lot of nice features in this new version, and we will be more than happy to present them to you on the 22nd of January. So I'd like to thank you all for attending this introduction to Diana webinar. Thank you to Jingming for giving this nice and comprehensive live demo. And I would say keep an eye on our website. There are always something going on. So just make sure that you are registered to our newsletter to get the latest news and event regarding our company and software. Thank you all. Bye.